Welcome. This video series is looking at the proof of the mean value theorem. This is the second part of a series. In this video, we'll talk about the proof of Rolle's theorem, which is a theorem about turning points. Here's a possible way of stating Rolle's theorem. It's about a function, so f of x is going to be our function, and its domain is going to include an interval. So we're focusing on just a closed interval. That's important, that this has to be a closed interval. And we look at our function and we need to decide if it's continuous or not. So Rolle's theorem is about functions that we know are continuous on that whole interval. And notice the endpoints are included. So the limits and the values of the function reach those endpoints. Secondly, this function has to be differentiable, meaning that the derivative exists at every point between a and b. Notice a and b are not included for this. The third condition of Rolle's theorem is that the endpoints are at the same value. F of a equals f of b. The most common application of this is they're both equal 0. Rolle's theorem then guarantees that there exists a value c which is between a and b. So this says c is in the interval a to b, and at the point at c, f prime equals 0. All right. This theorem we're going to build off of Fermat's theorem. Our strategy uses the fact that continuous functions have extreme values, and if we have an extreme value, Fermat's theorem guarantees that the derivative has to equal 0. And in some sense, that's actually the entire proof. So let's go through the steps. We start with our function f of x, and we know it's continuous on this closed interval. And there's a theorem called the extreme value theorem that guarantees that this function must have a maximum and a minimum on the interval. When we're doing the extreme value theorem, there are technically, three possibilities. I might have my extremes at the ends. I might have one extreme at the end at a max and one at the interior. So here's a max and a min on the first. Or I might have, a maximum and a minimum interior. Okay? Now, one of the requirements for our function is that f of a equals f of b. And so this first case is thrown out. We can't have one side bigger than the other. In theory, we could have a point that's an extreme at an end, or I might have the second case. The key, though, is that there is at least one extreme between the endpoints. So f of x must have an extreme at an interior point. We'll call that point, that'll actually be the c value we're looking for. Okay, so we have this interior point. By Fermat's theorem, because this function has a derivative, we know that the derivative f prime at c must equal 0. And that's the end. Ta-da! So this theorem is actually pretty quick. Once we know Fermat's theorem, and we know that a continuous function has an extreme value, then I go to the extreme value, I look at it, it has a derivative, and its derivative is 0. And the pictures I drew give examples of such points. All right, so Rolle's theorem is this idea that anytime a function is starts and ends at the same point on an interval, then somewhere in between it has to have a 0 slope. Well, how do we use Rolle's theorem in practice? Honestly, the biggest use is to prove the mean value theorem. But separate from that, Rolle's theorem is sometimes used to guarantee that a derivative has a 0 between the zeros of the original function. So if I have a function, so this is going to be my f of x, and let's say I create a function f of x so that I've got a 0 at -1 and a 0 at 3. Okay? And I try to draw a function That's going to be continuous and differentiable, so no corners or breaks. It needs to be smooth and never go vertical. As I draw this function, eventually I have to turn around, and at this turning point I have a slope of 0. So there's this interior point where f prime of x equals 0. So if I had a polynomial x times x squared minus 4, and it has roots at -2, 0, and 2, and that's going to be a cubic, x cubed minus 4x. This graph looks like every other cubic we see, and so I've got zeros at -2 and 0, and notice in between there's a point, there's a critical point. And also between 0 and 2, there's a critical point. Between every zero, or every pair of zeros of a function that's differentiable, we can find a turning point. All right, so our next video we'll be talking about Rolle's theorem and how it's used to prove the mean value theorem.